Alright, so hi, we will continue with Vesper part, the next part of Vesper, which we will involve the lone pair. So you already know that the Vesper is the electron pair around the central atom that will repel one another, and they will arrange themselves as far as possible. Why? To minimize repulsion. Okay, so remember that there are repulsion between electron and another electron. Okay, so you already learned a bonding pair is a pair of electrons that involve in bonding, and lone pair is a pair of electrons that do not involve in bonding. Okay, so we already go through for video part 1A for the basic shape which do not involve any lone pair. So if you have two electron pair which include sigma bond and lone pair, in this case we ignore the lone pair lah, no lone pair in this case. Just the general basic shape. So for AB2 means you have two bonding pair, the geometry will be linear and the angle will be 180 degree. So you can see by following this link given in the description. Okay, just click up to you want to choose model or the real molecule. So in this case I'll just use model. So first reset everything. Okay, so the purple dot here is the central atom. Okay, so for central atom, okay, let's say you have two bonding pairs, so add two bonding pair. Right, so tick here molecular geometry, it will give you information about linear and the electron also linear since no electron pair for lone pair. And then show the bond angle. So you can see the bond angle, no matter how you rotate it, it will still be 180 degree. Okay, so why? The electron bonding pair and this bonding pair of electron, they will arrange themselves as far as possible. So you can see the electron here is at the other end and the one bonding pair of electron is at the other end. Okay, so what if we look at the next example, which is trigonal planar. So for this case, for two number of electron pair, there are no lone pair involved. So ini you can just cross out lah. Alright, so next we will look at the next case, which you have three number of electron pair. So the molecular formula will be AB3, A as your central atom, B as your terminal atom. So there are three bonding pair 1, 2 and 3. So the geometry here will be trigonal planar, and let's just check. So just add here one more bonding. Okay, so what is the angle shown there between all the bonding pair? It is 120 degree. Okay, so no matter how you rotate between the bonding pair, okay, you can see each of them have the same angle. Okay, means the repulsion are equal. Okay, so they will repulse, and the repulsion of the electron, they will arrange themselves as far as possible. So it will result as the bond angle 120 degree. Okay, so what if, okay, so you can see here, I add one lone pair. Okay, I substitute one bonding here. Okay, you can see here, one bonding here, I substitute with one lone pair. Okay, so A masih lagi central atom. B bonding means 2 bonding and 1 lone pair, sepasang lone pair. Okay, what happened to the bond angle? So when you substitute the bonding pair of electron, okay, I substitute with lone pair. Okay, so you can see here, supposedly the repulsion here akan menolak. Okay, so means here the bond angle will be less than 120 degree. So why is this? Remember that the repulsion, the strength of the repulsion, the strongest is between lone pair and lone pair. Next is between lone pair with bonding pair of electron, and the weakest repulsion will be between bonding pair with another bonding pair repulsion. Okay, so next, let's have a look at the molecular geometry. Here will be band, or normally we call it as V shape. Okay, V shape of band. So the original or basic shape is from Trigonal Planar, and then you substitute one bonding pair with, here you can see, substitute here as your lone pair. So it will have geometry V shape. Okay, so let's have a look for the next structure. So for the next structure, we look at tetrahedral, which involve 4 bonding pair of electron. So let's say you have AB4. So this is the geometry which is tetrahedral. So let's see from this simulation. Okay, so you can see here, okay, so I arranged this molecule, one at the above, one pointing up, and the other 3 pointing down. So you can see here, if I rotate the molecule, okay, so how you draw it, one pointing up and the rest of it 3 pointing downward. So actually this one can be represented in 3D by dash and dotted line. Okay, so for the, when you substitute with electron of lone pair of electron, so you will get 1 okay, so you will get here in AB3E. Okay, E means lone pair lah for this one. Sorry that I forgot to write here. It should be AB2E. E means we substitute one of the bonding pair with this lone pair here lah. Okay, so this one AB3E. So central atom A bonded to 3B and 1 lone pair here. Okay, so I substitute with 1 lone pair. Okay, so what is this geometry? It will be trigonal pyramidal, right? So for this case, okay, let's have a look at the simulation. You remove 1 bonding pair, substitute with 1 lone pair. Alright, so actually when you substitute with lone pair here, the repulsion between this bonding pair will shrink. Okay, so the bond angle won't be 190. Okay, akan ada repulsion here, so dia akan less than, you can see here, the repulsion here akan menolak the bonding pair. So it won't be 109.5. Okay, so the bond angle between each bond will be less than 109.5 degree. Right. So next, let's have a look at the next case, which we have AB2, E2. In this case, we have how many lone pair? 2 lone pair. Okay. Right. So if you have 2 lone pair, means A as the central atom. So 1 lone pair here, and then another lone pair at one more side, and then your bonding pair will arrange themselves as far as possible. Okay, so this geometry will be, okay, so remove, add one lone pair. So here, okay, when you add lone pair, the bonding pair here akan ada repulsion, so dia akan jadi less than, okay, so the bond angle here akan jadi shrink. So means your bond angle between here, it will be less than 109.5 degree. Okay, so for your syllabus, you don't need to know the exact value. So you just need to know ada repulsion. Okay, so ini satu sahaja lone pair. So in this case, remember that repulsion between lone pair and lone pair adalah the strongest. Okay, so if you have 2 lone pair here, lone pair dengan lone pair akan menolak each other and they akan consume the space in 3D. So means the bond angle here will be smaller and smaller, okay, due to the repulsion. Alright, so the geometry here will be bent. Okay, so commonly known for this geometry is water molecule because you have H2O, means hydrogen as terminal atom, oxygen as central, and oxygen has 2 lone pair. Right, so let's continue with the next geometry. If you have 5 bonding pair, you will have the molecule as AB5. Okay, so the geometry will be trigonal bipyramidal. But what if I have 1 lone pair A? Okay, so the lone pair will be positioned at the furthest away from the rest of the bonding pair. So you will look at the bond angle 120 degree. Okay, so let's say you have 1, 2, 3, 4, 5. Okay, so this is your trigonal bipyramidal. Okay, so what if I substitute 1 bonding pair with 1 lone pair? So the lone pair will be positioned at the furthest away from the rest of the electron pair. So the rest of the bond angle. Okay, so if you have lone pair, 2 lone pair, so you can see here the position of the lone pair is the furthest away. So kita susunlah supaya senang kita lukis. Okay, this structure as your reference. So you have 2 lone pair here and 1 bonding pair here. Okay, it can be vice versa lah, terbalik macam ni. Okay, up to you. Right, so the lone pair here Okay, there will be repulsion between lone pair and the lone pair. Therefore, your bond angle here will be shifted or shrink. This angle will be less than 90 degree and this angle will be less than 90 degree. Okay, so the geometry for this is T shape. You can see the T shape here. Okay, or if you view from this side, it is T shape. One straight line and one straight line on the planar. Alright, so let's have a look if we have three lone pair. So remove one bonding pair and substitute with another lone pair. So you can see from top view, the lone pair will substitute at the bond angle 120 for the planar, right? So the remaining bonding pair is between the central atom with the bond pointing up and the bond pointing downward. Okay, so this structure as reference for you to draw the geometry. Okay. Right, so you have 1, 2, 3 lone pair. One, 2, and 3. Okay, so you can see the bond angle here is between this bond and this bond is 100 180 degree. So the geometry here is linear. Alright, so next, okay, there's no four lone pair. Let's move to the last one, octahedral. So what if you have one lone pair? Okay, so first we remove all 1, 2, 3, 4, 5, 6. Okay, so you can see octahedral, all the bond angle is 90 degree. Alright, so if you substitute one bonding pair with one lone pair, so the position of lone pair will be arranged as far as possible. So all the bonding will be distorted. Okay, so you can see from this view. Okay, up to you because it's just the same thing. Okay, this or from this view. Okay, so you have central atom 1, 2, 3, 4 bonding, and then one bonding pointing above and one here. Substitute with lone pair. Okay, so the geometry here will be square pyramidal. Okay, why square? Because the base here is square. Alright, next, if you have two lone pair, what will happen? Okay, so remove one bonding pair, substitute with two lone pairs. So the lone pair, remember that lone pair is the biggest repulsion compared to lone pair bonding pair. Okay, so for lone pair, they will arrange themselves as far as possible. Okay, so the structure here will be A as a central atom. You have 4 bonding pair and lone pair above and below your central atom. Okay. Right, so you have two lone pair here. So the geometry will be y square planar, square because the base is square planar. Okay, because when you view from above or below, you will have a plane. Okay, dalam bentuk satah lah. Okay, you can see this view. You can see it clearly, one lone pair above and below. They will rearrange themselves sejauh mungkin. Dia tak akan duduk sebelah-sebelah lah. Dia akan duduk satu atas, satu ke bawah. Okay, because bond angle between this and here with plane adalah 90 degree. So dia akan duduk sejauh mungkin. Alright, so that's it for molecular shape with and without lone pair. So I hope you will do your own version of your notes and I will check in face-to-face or physical class after this PKPB. So have your notes ready and make sure you understand the concept. And we will continue with next video. Thank you.